Today we will learn about the perceptron model in neural networks. It is one of the simplest and earliest ideas that shows how machines can train, learn, and make decisions. You must have seen a simple straight line equation in school. Y equals mx plus c, where m is the slope of the line and c is the y-intercept. Think of this equation as a machine. You give it an input x, it multiplies it by m, adds c, and gives you an output y. That's it. Now let's expand this idea. Instead of just one input x, what if we have multiple inputs? Say x1, x2, x3, and so on. Each input contributes differently. For example, imagine you are deciding whether to approve a loan or not. That is your output variable y. You take inputs like income as x1, existing debt as x2, and credit score as x3. So instead of y equals mx plus c, we now write something like y equals w1 times x1 plus w2 times x2 plus w3 times x3, and so on, plus w0. Now, what do these terms actually mean in simple language? Think of weights as importance attached to the inputs. If w1 is big, it means x1 matters a lot in deciding the output. If w2 is small, then x2 doesn't matter much. So weights are like volume knobs for each input, deciding how loudly each input speaks in the final decision. And bias, W0, is like a starting push. Even if all inputs are 0, bias can still shift the output up or down. It's like saying, even before I look at anything, I am slightly biased towards something. Now this is where the idea of neural networks comes into the picture. Instead of seeing this as just an equation, we can visualize it as a tiny unit called a neuron. Imagine a circle. Into this circle, multiple arrows come in, where each arrow is an input like x1, x2, x3. On each arrow we have respective weights, w1, w2, w3, deciding how strong that input is. We also assume that we have an input whose value is 1, and this arrow has weight w0, or the bias. So inside the circle, all these weighted inputs are added together, which also includes the bias w0. Then the neuron produces an output y. But neurons don't just give raw numbers. They usually pass this result through a decision rule. For example, if the result is greater than 0, the output is 1. Otherwise, the output is 0. This is like a switch, on or off. So the neuron is not just calculating values, it is deciding. This simple structure of inputs, weights, bias, summation, and decision is called a perceptron. It is the most basic building block of neural networks, also called the smallest thinking unit. The idea of the perceptron was introduced by Frank Rosenblatt in the late 1950s. His goal was to mimic how the human brain works, in a very simplified way. In our brain, neurons receive signals, process them, and then fire or not fire. The perceptron tries to do something similar using math. Now imagine connecting many such neurons together. The output of one becomes the input of another. Slowly, a network forms. This is what we call a neural network.